This is Edexcel Secure Mock 3, paper 2H. Question 1. Oliver records the distance from London to each of 8 cities in the USA. He also records the time taken to fly from London to each of these cities and shows this in a scatter graph. Part 1. Chicago is a city in the USA, and Chicago is 4,000 miles from London. By drawing a line of best fit, so this is really important, find an estimate for the time taken to fly from London to Chicago. So going back to our diagram, we need to draw a line of best fit, and it doesn't need to touch any of the points in particular, but it just needs to go through the middle following the pattern of the crosses. So we need to, it says that it's 4,000 miles from Chicago to London. So going back to here, on the distance axis, we go across and we go down. So look at this scale, that is 495 miles. So 495 miles. Be careful with the scales, each square is worth 5 because there are 10 squares for every time it goes up 50, so that'd be 495. It says, why is your answer to part I only an estimate? Well, I used a line of best fit, and these can vary slightly each time I draw them, so just put the fact that the line of best fit can vary slightly. Part B, it says calculate the gradient of your line of best fit. So the gradient is calculated by the difference in y divided by the difference in x. So going back to our line, the best way to do this is always to choose as big a triangle as possible, but I always choose where it goes through the corners of some points. So here, we can see that it goes through the corners quite easily. Now you could do a really big triangle and that would be the best estimate, but here it goes through the corners quite nicely. So the difference here is 500 and the difference here is 50. So 500 divided by 50 would give us a gradient of 10. It says give an interpretation of the gradient of your line of best fit. Well, the difference in y, the y-axis was the distance and the x-axis was the time. And we know that distance divided by time equals speed, so it's the speed of the aircraft. So the gradient is the speed of the aircraft. In this case, it's in miles per minute, but just the fact that it's speed is absolutely fine. Question 2, it says rotate shape S 90 degrees clockwise about the centre 5, 4. Label it T. So 5, 4, first of all, we're going to label that. The best way to do this is to draw around your shape using tracing paper, and then rotate your paper at 90 degrees, and you'll see that it ends up just here. Part B, it says describe fully the single transformation that will map T onto S. So this is T, and we want to go back to S. So we're going back the opposite way. So it's still going to be a rotation. It's still going to be 90 degrees, but this time it's going to be anti-clockwise because we're going back the opposite way. And don't forget to fully describe, you also need the centre of rotation. So the centre of rotation would be the same as it was before at 5, 4. Question 3, it says here are 2 rectangles, all measurements are in centimetres. The area of rectangle A is equal to the area of B. So the area of A is equal to the area of B. We then need to work out the perimeter of B. So we can use the fact that the areas are equal to work out what X is, and then we can substitute what X is to find the perimeter. So the area of this one is length times width, so 2.5 times 4x. So 2.5 times 4 is 10x's, so 4 lots of 2.5 is 10, so 10x's. And this one will be 7 times 2x minus 3. So 7 lots of 2x is 14x's, and 7 lots of 3 is minus 21. So if we put these two equal to each other, I've got 14x minus 21 is equal to 10x's. I can take 10x off both sides, which will leave me with 4x minus 21 equals nothing. Then I can add the 21 to both sides, which gives me 4x equals 21. And then divide by 4, and we get 21 divided by 4 is 5.25, or 5 1/4. Substituting that in, we're working out just the perimeter of B. So 2 lots of 5.25 is 10.25. Sorry, 10.5. And we need to take away from that 3. So 10.5 take away 3 is 7.5. So the perimeter will be 7.5 plus 7.5 plus 7 plus 7, which is 29 centimetres. Question 4. The diagram shows a fair four-sided spinner. Is going to spin the spinner twice and complete the tree diagram for this. So the probability of getting A is 3 out of 4, and they're all equal pieces, so it's 3 out of 4. And the probability of getting a B is 1 out of 4. And that's not going to change because the spinner can't change sides or change shape. So it's going to be 3 out of 4 probability there, and 1 out of 4, and 3 out of 4, and 1 out of 4. It says work out the probability that the spinner will land on A first and then B second. So we want it to go on A and then on B. So we want A first and we want it to land on B second. So it's going to be 3 quarters times 1 quarter, which is 3/16. Question 5. If S equals pi squared brackets B squared minus A squared, and A equals 8 and B equals 10, calculate the value of S. Give it correct to 3 significant figures. So again, lots of people just put this in a calculator and get it wrong and don't show any working out. So it's really important that you show this first step of working out. Now, if you put that in your calculator correctly, you should get 355.3 and etc. We only want it to 3 significant figures, so this is the only one that's important. So it'll be 355. Question 6. It says only blue vans and white vans are made in the factory, and the ratio of blue vans to white vans is 4:3. Write down the fraction that are blue. So blue is the 4 and white is the 3. So there are 4 blue vans out of 7 altogether. So a fraction is out of how many there are altogether, so 4/7. For the blue vans, the small vans to large vans is in the ratio of 3:5. Work out the fraction of the number of vans made in the factory that are blue and large. So the fraction that are blue is 4/7, and, so we're going to multiply these together, we want the ones that are large. So small to large, the large is the 5, so it's going to be 5 out of 8 vans made that are blue would be large. So we multiply that together, 4 times 5 is 20, and 7 times 8 is 56. And again, you can simplify that down to 5 over 14. Question 7. Find the reciprocal of 5. To find the reciprocal, you just put it as 1 over, so it'd be 1 over 5. Use your calculator to work out the cube root of 5 tan 60 plus 1. But we're using the trigonometry settings here, so we need it to be in degrees because the angle that we're using there is in degrees. So make sure you calculate it on degrees first, put that in and make sure you do it exactly as it says on there, and you should get 2.129754359. Question 8, it says make t the subject of p equals root a plus t over 2. So if we look at t, the first thing it's doing is being divided by 2, so I'm going to note down what's happening. Then we're adding a to it, and then we're square rooting it. So to undo this, we're going to start with p, and we're going to undo all that in reverse order. So the opposite of square rooting is squaring. So I'm going to square both sides, and I get left with that. I'm then going to take a off both sides, and I get left with that. And then the opposite of dividing by 2 is times it by 2. So times both sides by 2, and don't forget to multiply it all, you need brackets there. And multiply both sides by 2, you get that. Question 9. In the diagram, A, B, C and D, E, F, G are parallel lines. Angle AB is X, as it's labelled. Show that, EB and EF are equal to each other. Again, that's been shown by these little lines here. Show that W equals 90 plus a half X, given reasons. So the really important bit is we need to give a reason for each stage of our working out. So the first thing that I know is that alternate angles are equal. So this angle here is going to be X as well. So angle BEF, so angle BEF equals X degrees because alternate angles are equal. I also know, since this is an isosceles triangle, these two are going to be the same as each other. And we also know that angles in a triangle up to 180. So angle EBF is going to be equal to angle BFE, which will equal 180 minus the X over 2, because we need to half it. So 180 degrees in a triangle, take the X off and half it. And that would be equal to 90 minus a half X. And the reasons for that is base angles in an isosceles triangle are equal, and also and angles in a triangle add up to 180 degrees. So we now know that this here is 90 minus a half x. Now we also know that angles on a straight line add up to 180. So to work out W, we're going to do 180 minus 90 minus a half x. Now 180 minus 90 is 90, and subtracting the negative is like adding, so it'd be like adding a half x. So we're 90 plus a half x. So that's exactly what we worked out, like it said, but we need to write down the reason for that, and that's because angles on a straight line add up to 180. Question 10. In 2016, the population of the UK was 6.5 times 10 to the 7. Laura wants to calculate an estimate for the population of the UK in 2020, and she assumes that the population increases by 0.6% each year. Use this assumption to calculate the population in 2020. So, population now is 6.5 times 10 to the 7, and to increase by 0.6%, you'd multiply by 1.006, and from 2016 to 2020 is 4 years, so to the power of 4. And that would give us 6.657 times 10 to the power of 7. Kieran also assumes that the population of the UK increases by 0.6% each year. He says that it will take over 80 years for the population to increase by 50%, because 50 divided by 0.6 is 83.3. His method is wrong. Explain why. Well, he's assumed that 0.6% is going to be the same figure each year, but it's not. It's a compound growth. So we just need to write the growth is compound. That means it changes each year with a percentage, not simple. Where simple growth, like simple interest, would be the same amount each year. It says, assuming that the population of the UK increases by 0.6% each year, show that the population of the UK forms a geometric progression. Now, a geometric progression means it forms a sequence that, to get from one term to the next, you multiply by a number. So, the population is increased using the multiplier (1.006). So since each term is generated using a multiplier, it is a geometric progression. So you just need to know that geometric progression is calculated by using a multiplier to get from one term to the next. Question 11, it says Anna and Bill share some money in the ratio of 2 to 5. Anna gets A and Bill gets B. Carl and Donna share twice as much money as Anna and Bill, and they share it in the ratio of 3 to 1. Put your ratio as A to B to C to D. Well, first of all, the ratio 2 to 5 has 7 parts, and the ratio 3 to 1 has 4 parts. Now we could do this using algebra, or we could do it using an example of an amount of money. So I'm going to use it using an example amount of money. It's a little bit more common sense. So if this amount of money is split up in the ratio into 7 parts and also into 4 parts, it must be a common factor of 7 and 4. So, sorry, common multiple of 7 and 4. So the lowest common multiple of 7 and 4 is 28. So if these share £28 and these share twice as much, they must share £56. So 28 shared in the ratio 2 to 5, we divide by 7, which gives us 4. So Anna must get 8, so 4 times 2, and 5 times 4 is 20. So Bill will get £20. The £56 shared in 4 parts would give us £14 per part. So that would mean 3 lots of 14 is 42. And 1 lot of 14 is 14. So the ratio would be 8 to 20 to 42 to 14. Now each of those are even, so we can definitely divide by 2. So if we divide by 2, we get 4 to 10 to 21 to 7. Now we know that 7's prime, and 7 doesn't go into the other one, so we can we can leave it at that. Question 12. Here is a triangle PQR. The length of QR is 60% of the length of PR. Find the value of sin QPR. Now, basically we need the value of angle QPR here. And we know that QR is 60% of PR. So we can just choose two numbers where that is 60% of that. Now I'm just going to use the simplest ones, 60 and 100, because 60 divided by 100 is 60%. So this is the opposite, and this is the adjacent. So we can first of all we'll call this x. Tan x is equal to 60 over 100. So x will be tan to the minus 1 of 60 over 100, which would be 30.96 degrees. Now leave that in your calculator, because it is a bit more than 0.96. Now it's after the value of sin QPR, so we just need to put sin of that number that's still in your calculator, 30.96, and that will give us 0.514 to three significant figures. Question 13. Here are 5 graphs. Each graph shows either direct proportion or inverse proportion. The table shows 5 equations. Match the equations. Now, the first one I'm going to look at is B, because that's a linear graph. So down here, the one that I know is a linear graph is this one, because it's just got a value of x being multiplied by a constant. So that must be B. The second one I'm going to look at is the next one that I know the shape of, which is this quadratic here. So a parabola means it's a quadratic, and the quadratic one is here. So kx squared. So x squared is quadratic, so that must be D. The next one I'm quite familiar with is this one, which is a cubic graph. So a cubic graph is an x cubed graph, so this one would be, this one is E. The next two I'm not so familiar with, but I can use a little bit of common sense to decide which ones are which. This one is a square root of x. Now I know that the square root of anything, I cannot square root a negative number. So if we look at this graph here, there's no part of the graph in the negatives. That's because I can't square root a negative. So this one must be C, which means that this one must be the 1 over x graph, which is A. Question 14. A cafe owner sells 10 different types of sandwich. Raheem buys a different type of sandwich each day, so that's really important. On Monday, Tuesday and Wednesday. How many ways can he do it? On the first day, he has 10 sandwiches to choose from. On the second day, he's only got 9 sandwiches to choose from. And on the third day, he would only have 8, because each day he's got, to make sure it's different, he's having 1 less. So 10 times 9 times 8 would be 720 different ways they could have sandwiches on those 3 days. Question 15. The table shows information about the times a group of students took to do park run. Draw a histogram of this information. So the first thing we need to know is that we need to work out the frequency density, and it's given us a bit of a clue on this one, so this was quite good to work out the frequency density. And the frequency density is given by the frequency divided by the class interval. So on this one we do 20 divided by 25, because the class interval is 25. Divide this one by 20, this one by 15, this one by 15, this one by 10, and this one by 10. And if you do all those, we get that the frequency density for that one is 0.8, 1.75, 3, 5.8, 1, and 0.8. So from here, we can see that we've got enough squares to go up to 6. So 1, 2, 3, 4, 5, 6 quite easily. And that would mean that each square is worth 0.1, which makes it quite easy for us. So the first one is going to be 0.8 tall, and it's going to go up to 25. So 25 is right in the middle here, and 0.8 is just here. So we need to be really careful to make sure we go to the middle and go to there. The next one is 1.75 and goes up to 45. So 1.75, again, going up through the middle of here. We'll just go to there. And all the way up to 45. Just there. A lot easier when you've got actual paper to do it on a ruler. The next one will go up to 3. So I'll carry this on up to 3. And that would go across to 60. So a little bit of an easy one to go up to here. The next one it goes up to 5.8 and goes up to 75. So 75 is just here. And it goes up to 5.8, which is just here. Oh, be really, really accurate with these, make sure you use a ruler and a pencil. The next one is at 1 and goes up to 85. And the last one is at 0.8 and goes up to 95. Question 16. Show that the equation x cubed minus 3x squared plus 3 equals 0 has a solution between 2 and 3. Well, if it has a solution between 2 and 3, it must be that one of these, when you substitute one of these in, it will give a negative answer, and when we substitute the other one in, it will give a positive answer, because that would mean that in between those two, it would be 0, because it crosses from a negative to a positive. So if we substitute that in, we have 2 cubed minus 3 lots of 2 squared, add 3, and if we work all that out, we'd have 8, take 12, plus 3, which equals minus 1. If we do 3 cubed minus 3 lots of 3 squared plus 3, that will give us 27, take 27, plus 3, which gives an answer of plus 3. So you can see that one gives a negative, one gives a positive. So we just need to write down what it means. So since there is a change in signs, there is a change in signs, there must be I'm going to put at least one root, because it could be that there are 2 roots, because a cubic graph goes like this. So it could be at least one root between 2 and 3. It could be that there are 2 roots, but we'll just put it as that. It says, show that the equation x cubed minus 3x squared plus 3 equals 0 can be arranged to give x equals the cube root of 3x squared minus 3. So all we're going to do here is we're going to leave the x cubed where it is. We're going to take the 3x squared on the other side, it becomes a plus 3x squared. Take the plus 3 over, it becomes a minus 3. And then to get x on its own, we would cube root that. So we have cube root of 3x squared minus 3. It says, starting with x naught equals 2, use the iteration formula, xn plus 1 equals cube root of 3xn squared minus 3 to find the value of x2. So to find x1, we would just put x0 into that. So we'd do the cube root of 3 lots of 2 squared minus 3. And that will give us the cube root of 9, which is 2.080. You can just leave that in your calculator. And then to find x2, we'd just put this value here into our formula. So it'd be the cube root of 3 lots of 2.08, and make sure you use the full amount, squared, take 3. And that will give us 2.153, and that's just 3 decimal places. Question 17. A factory makes ice cream tubs in 2 sizes, small and large. The tubs are similar in shape, so that means they're in enlargement of each other. The height of the small tub is 5, and the volume of the small tub is 150, and the volume of the large tub is 500. Work out the height of the large tub. So we need the scale factor for lengths to get from the height of the small tub to the height of the large tub. We do know the scale factor for volumes. So the scale factor for volumes is 500 divided by 150, which is 3.3 recurring. Okay, well that's the scale factor of the volumes. To get to the scale factor for the lengths, we would need to cube root that. So the scale factor for lengths is the cube root of 3.3 recurring, which is actually 1.493. Carry on, again leave that in your calculator. So if the height of the smaller one is 5, to get the height of the bigger one, we do that 1.493, leaving the full number in your calculator, multiplied by 5, which gives us 7.469, and so on. It asks for, 469. So that'll be 7.47 to 3 significant figures. Question 18. X minus 8 brackets x plus 4 equals x minus a squared plus b. So basically this means we need to complete the square and work out what a and b must be. So the first thing we're going to do is expand the brackets. So we'd have x squared minus 8x plus 4x minus 32. And that will give us x squared minus 4x plus, minus 32. So to complete the square, we half the amount of x in the middle. So it would be x minus 2 squared. X minus 2 squared will give us x squared minus 4x plus 4. So to get to the minus 32, we need to take 36 off, because 4 take 36 gives us the 32 that we're after. So it says, in the brackets originally, we had minus a. So a must just be 2, not minus 2, just 2. Because it already had the minus there for us. And b must be minus 36, because originally it was a plus b. So it'll be minus 36. Question 19 says the diagram shows a sector of a circle of radius 9 centimetres. The sector has a perimeter of 25, work out the value of x. So if it's got a perimeter of 25, 9 add 9 is 18, so this here must be 7 centimetres. So to work out the value of x, if we had x, and to work out this 7 here, what we would do is we would do x over 360, so that fraction of the circle, times pi, times the diameter, and the diameter would be 18. And that would give us the answer 7 that we've already got up there. So to work out what x is, we just do 7 divided by pi and divided by the 18, and we need to multiply that by the 360. So x must be 44.56 going on, and to one decimal place that would be 44.6 degrees. Question 20. M equals 1 over ps. P is 5.37 to correct to 2 decimal places, and S is 2.9 to 1 decimal place. Calculate the upper bound for M. So to work out an upper bound, we would need the 2 lower bounds for these, because dividing by a smaller number gives us a bigger answer. So 5.37 will go anywhere from 5.365 up to 5.375, and 2.9 would go from 2.85 up to 2.95. So if we're after our lower bounds, so that will give us the upper bound, we'd do m is equal to 1 divided by 5.365 multiplied by 2.85, which will give us 0.0654011. Carry on. Question 21. It says, the diagram shows an acute angled triangle ABC. Prove that the area of a triangle ABC is a half AB sine C. Well, the first thing we need to know is that the area of a triangle is base times height divided by 2. Now, on this triangle, we don't have the height, but we can draw it in. The height is here, and the height is always at a right angle. So now we've got a right angled triangle here. This angle here is angle C, and this is the angle that we're using. So angle C would be equal to, sin of angle C would be equal to the opposite, which is the hypotenuse, over, the opposite, which is h, the height, over the hypotenuse, which is b. So h over b. So to work out h, just take b on the other side, we have b times sin c is equal to h. So even though we don't have the values, we can just do it in algebra. So h is b times sin c. And putting that into our original equation, we've got a half times the base, which was a, times the height, which is b sin c. So the area of this triangle is a half AB sin c. Question 22. It says a solid cuboid has a volume of 40 centimetres cubed. The cuboid has a total surface area of 100 centimetres squared. One edge of the cuboid is 2 centimetres. Find the length of the diagonal of the cuboid. So we're going to have to do this using algebra, because we've only got one distance here, which is 2. We'll call this one x and we'll call this one y. So the width and the length of this is x and y. We're told that the volume is 40. So to work out the volume of a cuboid, our first equation is 2 times x times y, or 2xy, is equal to 40. So 2xy is equal to 40. And our second equation is for the surface area. Now the surface area would be this area here, which would be 2x, and there'd be another one of those on the other side. This one here, which would be 2y, and one on the other side, and the bottom, which would be x times y. And that equals 100. And if we simplify that through, we've got 4x plus 4y plus 2xy's equal 100. So these are our two equations. this first equation we can rearrange to find out what either x or y is. I'm going to rearrange it to find out what y is. So rearranging that, I can divide by 2 and divide by x. So 40 divided by 2 is 20, and divided by x is 20 over x. So y must be 20 divided by x. And if I substitute that into this equation here, I've then got an equation with just x in it that I can then solve. So substituting that in, I'd have 4x plus 4 lots of 20 over x, which is our value for y, plus 2x times 20 over x equals 100. Now, if I multiply that all out, I'd have 4x plus 80 over x plus 40, because 2 times 2 is 40 and x divided by x is just 1, equals 100. And I've got a divided by x here, so I want to get rid of that. So divided by x, to get rid of that I need to multiply through by x, but I need to multiply everything by x. So if I multiply everything by x, I would get that, which is now going to be a quadratic that I can simplify. So getting everything on one side, I'd have 4x squared minus 20x's, minus 60x's, because they were originally 40, take off the 100 would be minus 60x's, plus 80 equals 0. And then I can, all these are a multiple of 4, so I'm going to divide through by 4, just to make my life a little bit easier. So x squared minus 15x's plus 20 equals 0. Now I could put that into the quadratic formula. So quadratic formula is minus b plus or minus b squared minus 4ac all over 2a, where a would be 1, b is minus 15 and c is 20. So minus b, so minus minus 15 would give us plus 15, plus or minus the square root of minus 15 squared, take away 4 times a, which is 1, times c, which is 20, all over 2 times a, so 2 times 1. Now, if you put all that into your calculator, you'd end up with 15 plus or minus the square root of 145, all over 2. And that will give us two answers. We'd either have 1.479 or 13.52. Okay. Now, because it gives us two answers, one of these answers is going to be for x, and one of these answers is going to be for y, because this original equation was symmetrical, and I could have rearranged this either way around. So one of these is going to be for x, and one of them is going to be for y. So we know, it doesn't matter which one, but we've written x as the smaller one. So x is going to be 1.479. and y is going to be 13.52. And to use Pythagoras in 3D, we just, to find the diagonal, we would just do the square root of 2 squared, which is one of the sides, plus the 1.479, making sure you put the entire display in, squared, plus the 13.52, again with the whole display in, squared, and that will give us 13.74. So it asks for 3 significant figures, so the answer is 13.7 centimetres.